Alright, hi Year 12s, this is Mr. Lim here again, and this is our last video on equilibrium, woohoo, on the carbonate equilibrium systems. Alright, so we're learning about carbon dioxide moving from air to water. Generally, we talk about it in the ocean, but it can also be inside your bloodstream. There's a carbonate equilibrium to make sure that you can get rid of the carbon dioxide from your body. And so we're just going to talk about it and we'll see how we go. Alright, so carbon dioxide from the air to the water. So first of all, we say that the carbon... Well, first of all, we should probably write down what all of these are. We'll do that as we go through. But carbon dioxide gas, so we all know that carbon dioxide is CO2. All right, so CO2 gas going to carbon dioxide aqueous, which means that the carbon dioxide molecule is dissolved in the water. When the carbon dioxide is inside the water, it can react with the water to form carbonic acid, which is H2CO3. Right, and that's an aqueous molecule, which is acidic, which can then break down and hydrolyze with water to form hydrogen carbonate ions. Okay, these are all reversible reactions, and hydronium ions, which are H3O+. Okay, so those hydrogen carbonate ions can further react with water to produce carbonate ions and hydronium ions. Okay, and then some organisms in the ocean use calcium ions with carbonate ions to form calcium carbonate, CaCO3. Okay, and so all of these equations are reversible and they can be combined at various levels to produce different equations. But the idea is that the carbon dioxide dissolves in the water, reacts with the water to produce carbonic acid. The carbonic acid with water produces hydrogen carbonate ions. All right. And those hydrogen carbonate ions can fall further hydrolyzed carbonate ions, but generally that doesn't occur as much. All right, so let's move on and let's have a look at what these happens with these 5 equations. So we generally talk about it in terms of the effect pH has on the levels of carbonate on the water. Okay, so the idea is that when you have this carbon dioxide, it goes into the water, it will change the pH of the water. pH is how acidic it is, and why does it changing how acidic it is? It's because there's the production of these hydronium ions when you do that. All right. So the ocean is naturally basic. A high pH means a low concentration of hydronium ions. So the ocean itself is naturally basic. But when you put in more carbon dioxide gas into the atmosphere and then into the water, it becomes less basic. All right. It is unlikely that there will ever be enough carbon dioxide to be added to the ocean to make it acidic because there's a lot of water. But the idea is that the carbon dioxide decreases the pH of the water and adds hydronium ions to the water. Right? So it makes it slightly less basic, slightly less basic, not necessarily more acidic. Right? So the carbonic acid reaction has a relatively high K value, which means that there's not many hydronium ions are going to return to carbonic acid. So where's that equation? It's up here. All right. So this equation here, this carbonic acid plus water, hydrogen carbonate ion and hydronium ions, this one here is unlikely to go backwards, but more likely to go forwards. Why? Because there is a high K value. High K value for that particular reaction. All right, so you're going to end up with lots of hydrogen carbonate ions and lots of hydronium ions. Most of them will be there. The hydrogen carbonate ion reaction, however, has a much lower K value. And so increasing the hydrogen ion concentration will significantly make that reaction go towards the left. Okay, so shift towards the left, favor the reverse reaction. All right, what does that mean? That means that this reaction here, the hydrogen carbonate ion reaction here, goes backwards a lot more regularly because it has a low K value. Low K value. Because it has a low K value, that means that any additional hydronium ions is likely to push this one backwards. And where do those hydronium ions come from? They come from the first reaction. So really what's happening is that, let's use green, the carbon dioxide in the air goes into the water, that makes sense, and it forms carbonic acid. That carbonic acid turns into these two, And from those two, the hydrogen carbonate ions and the hydronium ions work or react with the carbonate ions to make even more hydrogen carbonate ions. And it reduces the amount of carbonate ions that are present there. Okay, so that's what happens. Why do we care about those decreased carbonate ions? Okay, because, so here we go, reduces the amount of carbonate ions in the water. Why do we care about those carbonate ions? Because carbonate ions are important for calcifying organisms. What are these calcifying organisms? It's an organism that turns calcium and carbonate ions into calcium carbonate to make their shells and stuff. All right, so these calcifying organisms, to make their shells, they need calcium and carbonate ions. You get rid of those carbonate ions, you make it harder to make shells. Okay, so looking back up here at this particular reaction, this is the reaction where the organisms are turning into shells. But because you have so little of this carbonate ion, because that went down, because of this, right? So that makes making calcium carbonate quite difficult if the carbonate ion concentration is very low. All right, what does that mean? That means that organisms have to either expend more energy to build shells, leaving them vulnerable to predators. Okay, they either produce thinner shells, which means there's less protection, or they just grow at a slower rate, which means that they end up being smaller organisms over the same period of time. All right, so these are the particular things that can happen to organisms which need the carbonate ions, but the carbonate ions aren't there because we've been pumping too much carbon dioxide into the atmosphere. And there's just a whole bunch of hydrogen carbonate ions, but they aren't good to these organisms. All right. Similar concepts occur inside the body when you are exercising. Your body is producing carbon dioxide, which isn't technically in the gaseous form, but in the aqueous form, which produces carbonic acid, which produces hydrogen carbonate ions. And those hydrogen carbonate ions can shift back into carbon dioxide in the lungs to go out of the body as well. And the idea is that it helps moves the carbon dioxide from your body into your lungs, or at least into the air part of your lungs, to be exhaled so that it can be gotten rid of. All right. It also keeps the pH fairly consistent as well. All right. So that's the idea behind this stuff here. There is some stuff about the idea that more carbon dioxide in the atmosphere makes the Earth hotter, which makes coral bleaching occur. But coral bleaching isn't what this is talking about here. It's more about the difficulty of producing shells, and that's this part of the chemistry. The coral bleaching is more of a biology thing, so we leave that alone. All right, so that's it. And that's all for equilibrium. Woohoo! Adios.